Welcome to Did You Know, the ESCO HVAC podcast, the show where we explore the cool, the hot, and the everything in between of the HVACR industry. Each week, we dig into the innovations, the insights, and the inspiring stories that power our trade, from the classroom to the job site and beyond. This episode is brought to you by this week's amazing sponsors: Daikin Comfort Technology, perfecting the air since 1924. Service Logic, people first, always. Hudson Technologies, 1 pound reclaimed is 1 pound not made. iConnect Training, supporting HVAC and refrigeration instructors, as well as the United Association of Journeymen and Apprentices of the Plumbing and Pipe Fitting Industry of the United States and Canada, built on excellence since 1889. Whether you're just getting started or you've been turning wrenches for decades like myself, there's always something new for us to learn. I'm Clifton Beck, and this is Did You Know, the ESCO HVAC podcast. Let's dive in. Jamie Kitchen, how are you doing today, sir?
I am doing fine. Thank you for asking. It's great to be on here.
Absolutely.
Always love talking about refrigeration and air conditioning components and equipment. So it's probably why I work in that industry. It's funny.
Yeah, no kidding. And, the one we're going to talk about today is one of the probably most misunderstood and definitely misdiagnosed components within our industry.
And what could that be?
I couldn't tell you how many posts I've seen for, it must be the expansion valve.
It's like a meme now, right?
No.
The dumpster's on fire outside in the parking lot. Oh, it must be the TXV.
Yeah. I've spent over 20 years in the field, most of that in commercial refrigeration. And changing expansion valves is really almost as elusive as a reversing valve, of which I've placed 2 in my entire career. Expansion valves, yeah, I've probably replaced 100 of them or so, but how many have I not replaced? Tens of thousands.
Yeah, I mean, if you look at the installed base, I mean, it's getting better. Whether this is too early to talk about this in the podcast, but when SEER 13 came in back in the mid 2000s and everybody went to TXVs, the industry, Danfoss included, woefully underestimated the amount of education and training required to get people to understand this. We just assumed it was a simple component that people knew.
Right.
But there was an entire generation of techs out there that had worked with nothing but pistons. Combine that with the valve that's not adjustable superheat wise, and it just blew up in flames, right? So it was unbelievable.
Well, then maybe we should step all the way back to the fundamentals, right?
Okay.
Like, how does a TXV work?
No. Okay, so remember back in science class, balance of forces, right?
Mhm.
And that's really what we have. If you look at the flat saucer part, soft flying saucer part on the TXV, inside of that, if you took the head off, inside of that's a diaphragm, a piece of tool steel metal, tempered. And on top of that, you have one opening force, and that's your sensing bulb pressure. Now, counteracting that on the bottom are 2 closing forces. The superheat spring pressure. This is what you adjust when you're adjusting superheat, as well as the evaporator pressure. So between those 2 and the bulb pressure, sensing bulb pressure pushing on top, those are the forces fighting for control of the TXV. If they're equal, nothing happens. But if one becomes greater than the other, it's going to cause a deflection in that diaphragm. If the diaphragm deflects down, it's going to push on a pin, which is going to push the valve stem or the valve seat away from the orifice opening, allowing more refrigerant to flow.
Okay.
All right. So that would be your sensing bulb heating up. The gases in the sensing bulb, liquid changing state to vapor, takes up more volume, pressure increases, drives the valve open. Let's say you're running your cooler or your air conditioning and you remove the heat out of the space. You don't need as much load anymore. The TXV is going, hold on a second here, man. The refrigerant's leaving the evaporator cooler now. So my sensing bulb is becoming cooler. Then the evaporator and superheat spring then start to close the valve and reduce the amount of flow into the evaporator. So this is what we call an adaptive control. It adapts to changes in load.
And I think one of the misunderstood components of that is that sensing bulb. A lot of technicians have never been explained that that sensing bulb actually has our refrigerant in it. It has a charge of refrigerant, and that's the correlation with the pressure. When we look at the temperature pressure relationship of refrigerants, we know that as temperature increases, so does our pressure. As temperature decreases, so does our pressure. And so we're utilizing that function via our sensing bulb.
In fact, you can say all the magic happens in the sensing bulb. 100%.
See that?
This is what determines how that valve operates. Do you want to open slow? Do you want to close fast? Do you want to open quick on low temp? How do you want to make that work, right? Because there's a mixtures of secret sauce in these bulbs. It's not just refrigerant, because remember, the pressure temperature relationship is not stable. It is different at low temperature compared to high temperature. So your drift would be massive between superheat and opening if you just had refrigerant. We put a whole bunch of stuff in there. And then we can limit the amount of liquid to make it what we would call a limited opening valve, right? So you don't overload the compressor. We can put a piece of charcoal in there, carbon, so that it releases slowly so that it doesn't hunt. There's all kinds of things we can do. It all depends on what you're trying to achieve. Ice machines are a good example. Ice machines have a very specific charge to adapt to how the evaporator temperature changes in an ice machine. It starts high when you first bring water in, and then it drops rapidly right at harvest time. And you have to not underfeed, and you certainly can't overfeed. So we adapt the bulb charges for that very specifically. In fact, we have an ice machine charge for the bulb charge.
Okay. Very cool. Yeah. So that it's not as fast and swift as a modulation.
Correct.
Completely makes sense. All right. So, the reason we went from fixed orifice metering devices into these, adjusting was really kind of for performance and efficiency, correct?
Yeah, there's a couple of things. Performance is definitely one of them, and efficiency is another. Now, let's back up here a little bit. If you look at refrigeration compared to air conditioning, they're kind of a different way in which how the TXV fits into there and how they deal with changes in load. So let's take your household air conditioner, all right? You have your thermostat on the wall. It's reading dry bulb temperature, so it's missing 50% of the energy in the air, but that doesn't matter. It's measuring dry bulb. And it says, hey, right, I have a load in the house. It brings the system on. So it's probably energizing the coil of a low voltage relay coil, right? And it brings that compressor on. And then it runs happily and it says, hey, it's getting cool enough in here. So then it de-energizes that relay, the compressor turns off. That's not how it works in refrigeration, usually. In refrigeration, the thermostat controls a solenoid valve in the liquid line. And it closes that solenoid valve. Everything is happily running because it's downstream. It doesn't know that yet. But suddenly the liquid stops flowing through the TXV and it stops flowing into the evaporator, and the evaporator gets pumped down, and your low pressure control, not safety, low pressure control, then cuts that compressor off. Now, here's where the difference between air conditioning and refrigeration is. In air conditioning, you want that TXV to stay closed, because that's where a big chunk of your energy efficiency comes from, is making sure that your high side stays high and your low side stays low, because you don't want them to equalize, because you have to spend all this energy getting them back to that again. In air conditioning, keep in mind, you have the evaporator pressure underneath, the sensing bulb pressure on top. They're going to get pretty close to each other. But you've got your superheat spring, which is also an additional closing force. Those two, evaporator, superheat spring, is going to close that valve and keep it closed, right? And that way you maintain that high pressure differential. Technically speaking, you could do the same thing with a piston, which is just an orifice, and put a solenoid valve in, all right?
Right.
And shut it down. So really, 6 of one, half dozen of another, but now you're adding something. You might as well just put a TXV in, right? Because it's the same idea. By the way, you know where the performance difference also comes from with a TXV versus a piston?
I don't know.
It's not as reliant on the outside ambient conditions. So what most people don't realize is a piston and a TXV are backwards to each other when it comes to superheat and self-cooling. So if you look at a piston, if it's hot outside, you've got lots of condensing pressure. So it's just banging the refrigerant into the evaporator. So your evaporator superheat is very low on a hot day outside. Seems weird, right? That's great. What happens if it's raining outside and it's wet inside and it's not that hot outside? Now you really don't have any flow into your evaporator. So how are you going to remove all of this humidity in the air, right, if you don't have that mass flow through your evaporator? The TXV, unless it's freezing cold outside, it's going to have enough high side pressure. It's going to open up because it sees that latent heat, that humidity. It doesn't care if it's humidity or sensible. It's going to treat it as load, and it's going to open up and deal with that. And so you get much better dehumidification with a TXV than you would with a piston. Now, your household air conditioning is not the best way to deal with dehumidification unless it's loaded all the time, like Florida or Texas or someplace like that. But where I live, there's always these off cycles, and ASHRAE says, oh, this ain't going to work very well. You need a secondary dehumidifier. So that's why you put that thing in your basement that runs and then shuts off and you forget to empty it all the time.
Right. Unless you're like my son and you just run it down to like 65 degrees.
Yeah, if you want to hang meat in the place, you can dehumidify really good with that. But your electricity bill is probably going to be a little unconcerning.
Yeah, exactly. So tell me about a new generation, the TR6 valve. Tell me a little bit about that.
So with Danfoss, we have really focused on manufacturers, OEMs, and this is not a surprise to anybody. And there's always been some frustration. But the reality is we're an engineering company and we speak manufacturer's language. And we talked about sensing bulbs. We talk about compressors, whatever. You know, if the engineers at a manufacturer need information, they want to work with somebody, we're those people. So we'll go in there and design things and come up with products specific for them that do a very good job. Where we recognize we need to do better is servicing that aftermarket, because now the installed base is massive. Millions of compressors we've sold and millions of TXVs. It's insane how much market share we have. So now that product is starting to age out where it's going to need replacement. And so this is where you get a little bit creative. And universality is a big, big deal in the aftermarket. If you can have one code instead of 5 codes on your truck or your shelf, you've effectively taken that real estate space and increased the value of it. Like, it's real estate value that everybody wants, whether it's on a truck or on a shelf. How many turns am I going to get? How much money am I going to make off of this compared to somebody else's product? So you're being compared to your competitor as far as that's concerned. So if you can take a valve like the TR6 valve, which is a valve that we sell millions of a year into the light commercial residential market. And the OEMs want a very specific product because it has to be tested for utmost efficiency. But the aftermarket is a different game. The aftermarket wants it to work. It wants it to work well enough that people are going to be happy. But at the same time, it wants flexibility. So if you come out with a code and you can put the different connectors for that, let's say you put the TXV in the box and you have different connectors. You have chat lift and AeroQuip or whatever. And then you put the insulation tape and the bulb strap. That's pretty standard. But remember how I said the sensing bulb charge is the secret sauce? What we did was we came up with a bulb charge so that the TXV will work with 410A, 454B, and R32. All in one.
Oh, there. Okay. Now you're getting somewhere.
And so this just takes that universal aftermarket replacement one step further. And you can do the same thing with scroll compressors, right? Pistons are a little bit easier, but scrolls have a fixed compression ratio. So you can't just dump any refrigerant in there because it's all going to get compressed the same amount, right? It's not going to adapt. So what we did was we have 410A and 454B universal scrolls. You can't do R32 in there without a lot of work because the pressures just aren't going to work out for you. And so
you bet
this is kind of where this whole game is played. So with TXVs, the easiest way to do this is to get business is that here's what you have installed. You got all these OEM code numbers. Here's what you need to replace all of those. And you simplify it as much as possible. As long as it's got to work, it has to be happy because nobody wants to install something and then regret it, right? So This is where you have that balance. It's a little bit more like the Wild West. It's a little bit of, we could never sell a product like this to a manufacturer. They throw you at the door, right?
Yeah, it wasn't as
Yeah,
specific
they
as
want
what they're
very,
looking
very
for.
specific. Sometimes ridiculously so, but it works for them. But in the aftermarket, it's a whole other thing, you know, because time is money. And so if you have the product and you can service it right away, that's a massive service you're doing to your customer, and it's a massive cost saving as well.
Yeah. Well, I look at it from, from that universality. I was a contractor. I worked at a distributor for many years. If I can keep universal parts around that can serve my customer very well in a variety of different applications, that's what I want to keep around. And that was one of the big concerns as we started making this refrigerant transition. Of course, the very first topic that we started hearing, oh, the pressures are going to be different again. Well, they're close. They're different, but they're close. And then, now we're going to have all these different parts that we're going to have to keep around. And so when we start looking at a valve that is designed to fit those two different generations of refrigerants, right, our R410A, as well as our R32 and R454B, I think it's going to be critical that we start looking at components like this that are easy to stock, easy to use, solves a lot of problems, and it just simplifies the whole transition. We're all trying to help make this transition smoother, and this is one of the ways we can do that.
Whoever comes up with the best solution, to me, this, if you want to call it capitalism or whatever, but whoever comes up with the best solution that works, they're the ones that are going to win, right? So if you can provide the service and the solution for people and let people, I often joke that Danfoss loves to make great products and then not tell anybody about them, because we are a very conservative company that way. Advertise. I guess, we probably should advertise that we have this, right, kind of thing. So as much as you joke, we are not good at that side of the business, right? But we need to get better.
Okay.
So,
well, I'll be happy to help that, because there's going to be a lot of contractors, as we move into these generations of refrigerants, that, that's a common part to keep around. So, I mean, as a contractor, are there any things that I really need to know about, or, have we kind of really went through that?
Yeah, I mean, you have to understand that the refrigerants are different from each other. I mean, in the sense that it's kind of like you take a couple of refrigerants, you mix them together, and then you kind of change that ratio and add something else. That's really all these are. These are not new creations. It's kind of like you take some of this, and some of this, and you mix it together. Let me try mixing this together. And so that's where the chemistry comes in. But inside the system, they act differently. And we all have tools now. Danfoss, Emerson, Sporting. We have tools now that will tell you, okay, if I switch from this refrigerant to this refrigerant, you can go through all the components. We have it in what's called our Cool Selector, a Cool Selector software. You can download it. It's free. There's no spyware in it, trust me. So you can download this, and it will tell you what's the capacity change in that TXV. What's the capacity change in that, even just a simple line component like a solenoid valve. Some of these are suddenly going to become oversized, because think about it. That solenoid valve, unless it's tiny, it's pilot operated. And if it's pilot operated, it needs a minimum pressure drop across it in order to work. It's about a half a pound. All right. So if you're suddenly getting 25% more capacity, and this stuff happens with these new refrigerants, through your solenoid valve, and your solenoid valve is already on the edge of being too big, now it's going to become erratic, because it's going to have too low of a pressure drop to assist that opening, and it's going to stick, and it's going to cause grief, right, all across the board. And so these are the kinds of things where it's not difficult. You just need the information to look at it. And so we're all putting this material out there. The idea is, where is it? How do you find it? The wholesaler, right, really is the key to this. The wholesaler, because as a manufacturer, Danfoss does not have that relationship with the contractors. That's the wholesaler. So working with the wholesalers, educating them, providing them with the resources so that they can in turn go out and support their customers. That's how I'm going to win, right, in the aftermarket, is making sure that the wholesalers have all the information and resources they need. At the same time, you also have to help them by creating pull, right? And this is what we're doing today, helps out, where people are aware these products exist, and they can say, hey, I heard some dude from Danfoss talking about a universal TR6 valve, right? What do you know about it? Oh, oh, we have them right over here, right? And so you kind of close that whole loop in this thing, from start to finish. And that's how you play the game in this one.
Yeah, no, absolutely. And it's a great solution. I encourage everyone to spend a little time, head over to danfoss.com, learn about the products, the TR6, and check with your local distributor. If they're not already handling it, say, hey, Danfoss has got a universal valve out here that I want you to stock for in the future. And I'll about guarantee they're going to be looking forward to that.
And we have a lot of smart guys who pretend to be account managers, sales guys, and they're actually engineers and technical people like me. We're more than happy to work with the wholesaler, come out and put training on. We have all kinds of training. Most of it is how to reduce callbacks, technical training, troubleshoot training, systematic startup, things like that, where you're saving time and you don't have to drive back to the job site to fix something when you're done. So that's again, kind of where this all comes down to. And we're more than happy to share this with you and take your crew through it. So there's a cheap plug for me on this one.
No, it should be. I mean, that's the reason that we're here. It's about solving problems, creating solutions, and getting you the contact to, learn more to make sure that we're all successful.
Yeah.
Jamie Kitchen, I am sure grateful for you and Danfoss hanging out with us, and I look forward to some deeper conversations in the future.
I hope so, because they're kind of just scratching the surface here, and I have to kind of hold back because I could talk all day about this. So.
I love it. Part 2 coming.
What's that?
Said part 2 coming to podcast.
Yeah, exactly. Oh, absolutely. And again, whatever you guys want to hear out there, let us know, because we're more than happy to discuss it. So.
Love it.
Actually, I was talking like this is my show. I'm sorry.
No, you are. I mean, that's the whole point of making.
I have a podcast too, taking the temperature on HVAC.
Tell me a little bit about your podcast before we hop out of here.
Same thing. I bring guests on. A lot of them are from within Danfoss, smart guys. I also reach out to external people who are on the tools, who are on the design side, or even run their own businesses and own podcasts, and kind of dive into that. And it's called Taking the Temperature on HVACR. And really, we're just looking at different things. And it's very, what's the word I'm looking for? Easy going. It's like a conversation like we're having today, where we dive through different topics. We have a couple of laughs. We usually realize that we learned more than we thought we were gonna, or we know less than we thought we did. It's all of these things can happen. So I hope you can tune in and listen to us when you're driving in traffic sometime with nowhere to go.
Love it. All right. Well, we thank you all for joining us, and we'll catch you all on the next episode.
Thank you very much.